Recording, we're recording.
You seem like Cocker.
Hmm?
You seem like Cocker.
No, this isn't Kali Linux or anything like that. Alright, let's continue. So, yes, what I'd like, just to get... Yeah, just to get started, what I want you to do, as neatly as possible, I want you to draw, let's say, y equals 6x minus 3, and y equals minus 2x plus 5. On the same graph, I want you to draw these as neatly as you can. And while you're doing that, let me just open this up here. Come back.
Like same point.
Yeah, well, I want you to draw the two lines on the same graph.
Yeah.
Yeah, some of you have it drawn.
Yeah.
So, on your graph, roughly where do they meet?
What?
What point do they meet on your graph?
X and Y.
Well, thank you. Thank you. I mean, couldn't possibly have guessed that. Could you give me numbers for x and y?
Like 0 minus 3. And
0 minus 3. I have a feeling we're going to get many different answers now. Anyone else? From looking at your graph, where did the two lines meet, roughly?
oh, where does it meet?
Yes.
1.13.
1, 3, you reckon?
Yeah.
Good, okay. Anyone agree or disagree with that?
Everyone is agreed.
Everyone agrees.
Yeah.
You see, this is how a dictatorship starts now. Your silence just encourages people. Does anyone disagree, or are you happy with it being 1, 3?
Yeah. Exactly.
Okay, yeah.
Yeah.
Yeah. No, you see, he's the voice of freedom. He's just disagreeing with you to disagree, right? I bet he does. No, he said. Did you say 1, 3 or 4?
4, 3.
Yeah, see, he's totally different. Yeah, that's it. Yeah.
It's like
Liberation Party. 4, 2. Okay, good. All right. Let me draw it nice and neatly for you on this graphing program. Let's see. What was the first one? Can we just call it out? Y equals, what was it? 6x minus 3. Okay, let's draw that. Okay. And then what is the other one?
C.
Y equals to negative 2
Yeah.
plus 5.
Plus 5x?
I mean 2x plus 5.
Minus 2x plus 5.
Yeah.
Like this. Okay.
Oops.
Yeah.
Listen to it.
It is 1, 3. Yeah. No, I'm as annoyed by that as you are. So, 1, 3. Now, what I'm just showing you here, well, what's the name of this point here? Intersection point. Yeah? Tell me, do the two lines, will they always have an intersection point?
No.
No. When they're parallel, they don't.
Yeah.
But apart from that, they should.
Yeah.
Right?
Only for
Now, this is the first method for finding the intersection point, but it's kind of not a great method because, you know, it wastes time during a graph. But that was still the first method. That's the graph method.
There was a method is.
Huh?
I know there was a method.
Yeah, but I'm sure a lot of people know other methods. What is the second method? If we call this method we'll say the graph method.
Like equation method?
Ah, yeah, but what are you doing? Yeah?
As in what?
Elimination.
Yeah.
Yeah, where we try to cancel it.
Yeah.
Okay. So, let's have a look at the elimination method. Okay. Find xy, and we'll have the two equations. Let's say 2x plus 3y equals 10, and we'll say 3x plus 5y. I don't know, we'll just make up one here. We'll say 20. Now, the answers won't work out nice and neat here. I think you'll get fractions, but let's see. So this elimination method, you all would have learned this in high school.
Yeah.
You try to make either the x's or the y's the same. So let's make the x's the same. We need to do two multiplications here.
Times 3 and 10.
3 and 2 will do it.
Yeah.
Okay? So now we get 6x plus 9y equals 30. And then 6x plus 10y equals 40. And then we're allowed to add or subtract. Subtract is what we should do here. 6x minus 6x, gone. 9y minus 10y,
Why will
minus y. Yeah?
equal minus 10 or like
Yeah, minus 10.
or like just y equal
Y equals 10.
yeah.
Now, after you get the y equals 10,
Just I just
sub it in.
Yeah.
Now, we could sub it into any one, but the easiest looking one is the first one, isn't it? That looks like it's not too bad. So 2x plus 30 equals 10. So 2x equals... Oh, so by accident they worked out to be nice. So x equals
Yeah. Minus 10.
minus 10.
Still minus 10.
So 10 minus 10, or minus 10, 10.
I knew it.
You do it. Okay. That's the elimination method. Probably the method you would all naturally use anyways from school. Okay. Two more methods to look at. So the next one is a substitution method. Okay, so once you write that down, we'll look at the next one. Now, it's possible in the exam they will tell you which method to use. So, it's not like you just need to know one of these methods, you need to know them all. They probably won't ask you to use the graph, although they could, they just haven't. Elimination and substitution are their most common. However, in fact, most common is they don't tell you which method, and you can use any method, but sometimes they say elimination, sometimes they say substitution. But it's okay. Right, 3. Method 3. Substitution. So that was elimination, this is substitution. Do you know what? We'll use the same two, but the substitution method. Now, what do we do in the substitution method? Some of you must have done the substitution method before, yeah? Yeah. That's it, yeah, make x or y the subject. What would you think? Which one would we pick and what would we make as the subject? There's not really any nice one, is there? Maybe the first one and we, what, x or y? A little nicer than y, I think. So, if you take this here and make x the subject, you get 2x equals 10 minus 3y. So x equals 5 minus 3 over 2y. And then what do we do with that? Substitute it in. So now we get 3 bracket 5 minus 3 over 2y because we've replaced the x. Plus 5y equals 20. 15 minus 9 over 2y plus 5y equals 20. Is that right? Yeah?
Yeah.
5y minus 9y, what's that? A half y? That's 10 over 2. Is it a half? No. It's a half, isn't it? Yeah, it's a half.
Yeah.
So we have a half y. And then if I bring the 15 to the right, 20 minus 15? 5. So look what we get, y is 10. And what's really nice is we just go straight back into this one.
Yeah.
5 minus 3 over 2 times 10 is minus 10. 5 minus 15 is what you would get.
Yeah. The second method is better.
Well, no, it depends. Well, in this case, yes, but it depends on the question.
Yeah, agree.
In this case, substitution wasn't great because you have to mess with fractions. It's not great. But sometimes it is. Like, you know, I won't do it, but if you had I could imagine if you had a question like this, let's say x plus y equals 2, and then 5x plus 3y equals 6. Well, that would be pretty nice for substitution, wouldn't it? Because you could get x or y here
Yeah.
quite nicely and sub it in. So that would be a good one for substitution. Yeah? Okay. Yeah?
X multiplied by y equals.
Yeah, and for
It's
multiplication ones you have to use substitution. Now we don't deal with any of those today, but maybe I think that's later then. The advantage of the substitution method is that it works for a wider range of problems. But the disadvantage of the substitution method is, you can see, it can be a little bit messier. Yeah? Yeah? Okay. Did you write that one down? Yes? Next one. So anyways, I haven't really shown you anything that you probably haven't seen before. In middle school even. Maybe high school. Okay? But the next method I want to show you, it works very well for very difficult problems. Gaussian method. Now, I don't know, some of you might have seen this before, or maybe none of you sometimes. Anyone know this method?
Probably like it's different translations or like.
I doubt that,
languages.
because Gauss is a name, it's a person. So, I'd imagine Gauss in Arabic is probably still Gauss. Yeah.
That's just trying.
Gauss. Anyone know him? No. Okay. Right, so we don't necessarily know this method. This method works really well for very difficult problems. So let's take an example. Let's say, like really something really messy, like 8 over 3 x minus 7 over 8 y equals minus 3 over 2. Something very messy like that. And then 5 over 2 x minus 5 over 6 y equals minus 5 over 8. It's quite messy. Okay. So just write that question down and then we'll have a look at how to solve it using this method. Okay. So I'll show you how Gauss works for this case, and then I'll show you Gauss in action for a case with x, y, z. So what we do is, rather than write x and y every time, we kind of summarize it in a block. Do you know it?
Yeah.
Now just be careful, because if you know it, you're going to tell me what to do.
Let's go.
Well, 8 over 3 minus 7 over 8 dot, 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 minus 3 over 2. 5 over 2 minus 5 over 6 dot, 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 minus 5 over 8. You put everything in a block. Now, what's next?
There's
Next.
Yeah, next.
Yes.
The step after this
Yeah.
step.
It's the most important one, you know?
Yeah. Oh no. First step in maths is always important. If you get that wrong, then the rest is a disaster.
Yeah.
Okay, so what we do in the Gaussian method is similar to the elimination. Now watch carefully because a lot of you haven't seen this before. We try to make these two the same again with a multiplication. Okay. Now, I know if I multiply by 3 and by 2, I at least can get rid of the 3 and the 2. But what would I be left with? An 8 and a 5.
Probably you should like multiply by 5.2 on.
Ah, but I don't want to have more decimals, you see. I want to try and get rid of the fractions here.
Yeah.
So I'm left with an 8 and a 5. What's the smallest number that I could multiply up between the two? I think it's 40, isn't it? I could make 8 become 40 and 5 become 40.
Yeah.
There's nothing smaller, right?
Yeah.
So that would need me to multiply this one by 5 and this one by 8.
Yeah.
So if I go for 15 and 16, 15 and 16, then I can make both of these guys become 40.
Yeah.
Now you will possibly need your calculator here because of the fraction. So 8 over 3 times 15 we said will become 40. And minus 7 over 8 times 15, I don't think that's going to be anything nice. I think that's going to be 105 over 8, is it?
Yeah.
It's 105 over 8. Minus 45 over 2?
Hold on, like 45
Yeah.
divided by 2 is 22.
No. We'll keep them as fractions now. Our life is hard enough.
Oh,
Yeah. 5 over 2 times... that's 40, of course. We did that on purpose.
Yeah.
3, 8, 40 over 3? Can someone confirm that?
Yeah.
Yeah.
Perfect.
10. Right?
Yeah.
Yeah.
Yes? You can confirm that? Okay.
Yeah.
So what we do now is, in this method, we are allowed to add or subtract rows and put the result on either row. So for example, what you can do here, you can either say row 1 plus row 2 and put the answer on row 1, or you could say row 1 plus row 2, put the answer on row 2, or you could say row 1 minus row 2 and put the answer on row 1, or you can put the answer on row 2. Now don't write all that down. What we usually do is we say row 1 minus row 2 and we put the answer on 2. So because we're putting the answer on 2, we keep the first row the same. Okay, let's do this one. Row 1 minus row 2, put the answer on 2. 40 minus 40, 0, put the answer on row 2. Now, I definitely will need the calculator here. Minus 105 over 8 minus 40 over 3. What's that? If someone could so kindly tell me that.
It will be.
At loss.
Come on, use your calculator.
Yeah. Give me a second.
What is it? 5 over 24. And then the last one here will be minus 45 over 2. Minus 10 is plus 10. What's that? Minus 25 over 2? Now, you realize this, or not, this is kind of the key in this process. Once you've made this guy a 0, you're actually finished. Because if you were to write this back in equation form, look at what you have. You have 40x minus 105 over 8y equals minus 45 over 2. And here you have 5 over 24y equals minus 25 over 2. Now why am I saying that practically finishes the problem? Well, what does this give you? What do we know from this line? We know y, don't we? Easy, right? We just bring the 24 up and the 5 down. And if we know y and sub it in here, what can we get? We can get x. Now you might say, well, I don't see how this is very different to the elimination method. Well, the next example I want to do really shows you how useful it is, where we have 3 of them, x, y, z. Okay? So if I'm going to stop it here because the rest is just substitution then. I want to show you an example with x, y, z. Can I scroll down? Not yet, okay. Yep.
To be honest, it's quite new for me, but I thought you like introduced variable. That's why I was like,
Oh, like a let u equal something.
yeah.
Not for these ones, not for the linear
Yeah.
ones. Maybe for a square, quadratic or something. Okay? No? No. I think what I'll do, if you didn't finish writing this down, no big deal. If you go to the YouTube video afterwards and go to 22 minutes, then you can get the image then, okay? So you can go to the YouTube video afterwards, just leave a little bit of a space and go to 22 minutes and you'll get it. Okay, next example now. Right, so here is the real benefit of Gaussian when you have 3 variables. So let's say we have something like 2x plus y plus 3z equals 6. Let's say x minus y plus z equals 1. And let's say 3x plus 2y minus z 4. Let's look at the Gaussian method in action here. So our block is 2, 1, 3, 6. And the next one is 1, minus 1, 1, 1. And the next one here is 3, 2, minus 1, and 4. And just to be clear, my goal, what I'm trying to achieve, like in the last one, is zeros in the corner. Except this time the corner is a little bit bigger. I want zeros here. I want to make those 3 numbers 0. Okay, let's try. The process is the same. First, we try to make all of these the same. What's the smallest number that does that? 6, isn't it?
Yeah.
3, 6, 2. Okay? 6, 3, 9, 18, yes? 6, minus 6, 6, 6. 6, 4, minus 2, 8. Okay? Now, let's think about which, is everyone okay with that? Yeah? Let's think about which rows to combine. So if I did row 1 minus row 2, and put the answer on 2, that would make this fella disappear. And if I did row 1 minus row 3 and put the answer on, what do you think? Which row? Well, not row 2, because I've already done something with that. Row 3, yeah. So let's see what happens if I do that. Which row is staying the same? 1 is staying the same. Okay. Row 1 minus row 2, put the answer on 2. No, no, guys, no, you need to watch. Shh. Row 1 minus row 2, put the answer on 2. 6 minus 6, 0. 3 minus minus 6, 9. 9 minus 6, 3. 18 minus 6, 12, isn't it? No. 12, yeah. Right, and now row 1 minus row 3, put the answer on 3. 6 minus 6, 0. 3 minus 4, minus 1. Next one, 11. And last one, 10. Now you see we're nearly finished. What's the last guy to get to 0? This one. So, what we could do is make these two the same. In fact, all I really need to do is take row 3 and just multiply it by 9. Because then this becomes minus 9. Yeah? So let's see what happens now. What rows are staying the same? First one stays the same. And what else? Second one staying the same. And this last one becomes 0, minus 9, 99, and 90. Now, what operation should I do next?
Row 2 minus.
Row 2, now be careful,
Plus.
plus
Everything right.
row 3. Put the answer onto row 3. Okay, so let's see what we get now. Which are staying the same? First two are, aren't they?
Yeah.
Right, row 2 plus row 3, answer onto 3. 0, 0. 9 and minus 9. Yeah, 3 and 99. 102. And 12 and 90. 102. Now, we're actually finished now. Because if I go back into equation form, what are my 3 equations? I have 6x, 3y, and 9z, isn't it? Equals 18. I also have 9y plus 3z equals 12. And then I have 102z equals 102. Yeah? What does the last guy give me? Yeah, the last guy, this gives me z equal to 1. Then what do I do with that? I sub it into this. And what does that give me? That gives me the y. And it turns out y equals 1 if you sub it in. You get y equals 12 minus 3z over 9. And z is 1. So you have 12 minus 3 is 9 over 9. So it works out to be y is 1. Then what do I do with that? Sub in here y and z. And what do I get? It gives me x. So y is 1 and z is 1. So that's 3 plus 9 is 12. Yes? 18 minus 12? 6. 6 over 6? 1. So I have here x is 1. So the answer is x is 1, y is 1, and z is 1 in this example. So what this method does is it takes a difficult equation and transforms it into simpler equations where you can run backwards, getting z, then y, then x. And the reason it works is because you make the zeros here. That's the trick. Has anyone seen this method before? Now it works really, really well the bigger it gets. Because if you have 4, then what's going to happen? You're going to have 1, 2, 3, 4, and a number. Then you have 0, number, 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 number. And then 0, 0, and then 0, 0, 0. Do I have that right? I think so. The triangle gets a little bit bigger as you go out. But it's the same idea each time. You make zeros here. Okay? Now, I'm only showing you this method if you want to use it. They won't ever ask you, they won't ever say you must use this method in the exam. Okay? But sometimes in semester 2, you might get a question with 3 variables in it, x, y, z. And I just think this works so well for when you have 3. Because it very nice and neatly takes a hard problem and turns it into a simpler one. It's why I like this method. Yeah? But like I said, you could use substitution as well, elimination, whatever. It works just as fine. Okay, so let me scroll down in case you need to write that down. The ones I want you to try, let's say, let's just do 1E, 1E. 2U let 3VW and we'll just give you 4A. 1, 2, 3, 4, 5 questions there. Okay, there's a few minutes left, so you can get a start on these now for your homework. Yeah? So in number 1, I just want you to do E. Just E. Number 2, actually I'll write it down here, sorry. 1E, 2U, 3VW, and 4A. You can get started on those.